So this is a quick demo of the Clickbait Detector machine learning model that I have on my GitHub portfolio. You can check it out and contribute if you want. So how does this work behind the scenes? Well, behind the scenes it is using a double stacked LSTM and an embedding layer whose weights were set using the glove embeddings. So let's dive right into it without further ado. So before we begin, we will set up some configurations so that this notebook works both on Google's Collaboratory and your local machine. Next up, we will import the libraries that we will be needing. Then we will import the dataset, which is called clickbaitdata.csv, and we load the glove embeddings into a vector, and let me quickly show you what the data looks like. So there is one column called headline. It has all the headlines, and besides that column we have a clickbait column which specifies whether that specific headline is clickbait or not. Then we perform some basic data cleaning operations. Next up, we will create a tokenizer and we will fit it on our text, and we will convert the text into sequences or vectors, and then we will pad the sequences with vectors with a max length of 200. Next up, we will define the model. So the model has two LSTMs like I said, and we have added an embedding layer, and we will load the glove embeddings into this embedding layer. And we have also set return sequences to true for the first LSTM and to false for the second LSTM. And we've also set recurrent dropout to 0.5 and layer dropout to be 0.1. Now let's move to the next cell. Here we are summarizing the model, and then we are setting up the embedding matrix to set up the weights for the embedding layer. And then we will compile the model using RMSprop as the optimizer and binary cross entropy as the loss. And we will train the model using early stopping so that the model monitors the validation loss, and this basically has a patience of 1, which means that if the validation loss does not decrease, the model will stop training. Then we will fit the model, and next up we'll save the model, and let us finally see the model in action. So the model has a testing accuracy of 92%, which is amazing. And we'll see the model in action. Let me clear this up. So we are defining two functions that will help us in predicting the sequences with ease. Now, click here is predicted as clickbait by our model. Next up we have this is amazing, which is also clickbait, and we have Trump finds out, which is also clickbait. Next up, what the heck, this is clickbait. You will never feel the same, which is also clickbait. And that's all for today.